Okay, as usual, we ran out of time, and we need a little bit more time to finish this video. It's graphs of functions, part 9. Here, plus minus changes sign in second derivative, right? From plus to minus and from minus to plus. So what do we have here? We have here a point of inflection, right? From concavity upwards to concavity downwards, then to concavity upwards, right? We have a point of inflection. Let's see. If we take the particular points here, if we take y equals 0, y is 3x power 4 minus 4x power 3. Y is 3x to the power 4 minus 4x to the power 3. If we take it equals 0, x cubed in common, 3x minus 4 equals 0. This gives me that x equals 0, and this gives me that x equal plus 4 over 3. At 4 over 3 and at 0, it cuts the x-axis, right? It's 4 over 3. Okay? So we have 0, 0, and we have 4 over 3, 0 points of intersection. Let's draw the graph. Let's draw the graph. Of this function. This is the y-axis, and this is the x-axis, right? As we can see, we have 0, 0 point of intersection. Let's make it first. We have 4 over 3, 0. What is 4 over 3? This is 1. This is 2. 4 over 3, it's 1 and 1/3. 1 and 1/3. This is 4 over 3. This is 1. This is 2. This is 4 over 3. This point here is very important also. What else do we have? We have 0, 0 as a saddle point. We have 2 over 3 minus 16 over 27. 2 over 3 is 2/3. Minus 16 over 27, it's like about, let's see, 16 divided by 27, we have 0.6 approximately. 2 over 3, which is 0.66, and 0.6, negative 0.6. It's minus 16 over 27. So this is 1 minus 0.6, somewhere over here. Okay, this is an important point. This is important point. And this is important point. What else do we have? This is a point of inflection also, right? What else do we have? Maximum point, I guess. Sorry, a minimum point, local minimum. It was abscissa 1, ordinate minus 1. Abscissa 1, ordinate minus 1, so it's here. And then we can draw. Look at the behavior of the function. It goes from plus infinity down to 0, 0. Then it goes from 0, 0 down to this point. It goes from plus infinity down to 0, 0 to inflection, and it goes back down to this point, right? It's like something like that. Okay, and then here into inflection again, concavity downwards, it will be concavity upwards to the minimum point, and then it go back to cut this point exactly, and it goes up. It's not perfect, but that's the figure. Let's see if we can do something else. Okay, in the other video I will explain activity about we will explain this activity. Let's just mention it. I will do this activity, which is y equal x minus 3 over 2x minus 1. How to draw this activity? As you can see that the degree of the numerator is equal to the degree of the denominator. In this case, if they have the same degree, for sure we have horizontal asymptote, and we have here because the denominator could be equal to 0, so we have a vertical asymptote. So we are going to work on this activity in the next video. Let's start. We can do it. We can do a big part of it. Okay, what is the domain of definition here? If this is called f of x, for example, what is domain of the function f of x? First, we take 2x minus 1 does not equal to 0. This means x does not equal to half. So domain goes from negative infinity up to half, open at half, union from half to positive infinity. So all the way in R, just excluding the half from R, right? Or we can write it, if you want, I prefer the interval thing, but we can write it like that, right? It's R minus half. What else we do have? Let's see the behavior of f of x, right? At the intervals. And let's take the limits of f of x. As x approaches to minus infinity, what will happen? It will be limit of only x over 2x as x approaches negative infinity. X will cancel, so it will be equal to half. In both cases, positive infinity, do the same thing. When x approaches positive or negative infinity, we take the highest exponent up over highest exponent down, right? And this will be y equal half is a horizontal asymptote. This is very important to take it to the graph, right? And limit of f of x as x approaches half minus means to the left of half to this point, right? And then limit as x tends to half plus will do what? Its limit of this function x minus 3 over 2x minus 1 when x approaches half minus. The answer will be half minus 3. The problem is in the denominator because 2 times half minus 1. It's half minus 3. Common denominator gives me minus 5 over 2 as a final result. 2 cancel, it's 1 minus, right? 2 times half minus, it's not exactly half, it's a bit less than half. So 2 times half will give me a bit less than 1, minus 1. Bit less than 1 minus 1 is negative 0. So it's 0 minus. Minus 5 over 2 over 0 minus, it will be plus infinity. And limit of f of x as x approaches half plus the same, right? Will be equal. Let's directly substitute. It's half plus minus 1, up we will have minus 5 over 2, but down we will have 2 times half plus 2 times a bit more than half, so it will be a bit more than 1. So minus 5 over 2 in the numerator never change, in the denominator will be 0 plus, right? Positive, negative divided by positive, it's positive infinity. In this case, we can deduce that x equal half is a vertical asymptote. Yes, we can know it directly from here or from here because we excluded this value. We don't have it. This means it will be a vertical asymptote. Okay? Let's find the derivative. It's x minus 3 over 2x minus 1. Again, f of x is x minus 3 over 2x minus 1. Right? What do we have here? Derivative u over v. U over v, the derivative is u prime v minus u v prime over v squared. What is the derivative of the numerator? It's 1 times denominator minus derivative minus numerator times derivative of denominator over denominator squared. And it is equal to 2x minus 1 minus x, sorry, minus 2x, right? We have to multiply the 2 with this and the 2 with this, and all of them multiplied with this minus. So minus 2x plus 6 over 2x minus 1 to the power 2. So the final answer of the derivative will be, it's 5 over 2x minus 1 to the power 2. For sure, 2x minus 1 is a positive value and not equal to 0 because x not equal to minus to 1 over 2. This one is positive value, so the derivative is positive value, and that makes that f is strictly increasing value. and we continue in the next video.